In the previous videos, we learned that sound is generated by mechanical vibrations and travels as waves or oscillations in the surrounding medium. In this video, we are going to look at two important properties of sound. So, what are these two important properties of the sound waves that we should really be aware of? Let us discuss these two properties in this video. The first important property about a sound wave is that sound waves require a medium to travel. We discussed in the earlier video that sound waves are mechanical waves and travel as pressure and density vibrations in the medium. This means that they need a medium like solid, liquid, or a gas to travel. But the important part to note is sound waves cannot travel in vacuum. In fact, we can actually prove this using a simple experiment. So here we have a very simple setup. What we have is an electronic bell, the bell that is shown over here, the bell jar. Now this bell jar basically has two connections. One is that it basically has a small electric bell that is connected through the switch to an electric connection. Whenever the switch is turned on, the bell starts ringing, right? And we also have another pipe that is put at the bottom of the bell jar, which goes to the vacuum pump. So this is our experimental setup. Now, what we do is we turn on the switch. When the switch is turned on, this electronic bell starts ringing because it provides current, the circuit is closed, and we keep on hearing the sound. Now what we do is we turn on the vacuum pump, and that starts sucking the air out of this bell jar. Now what you will notice as the air is sucked out is that the sound of the bell gets fainter and fainter. And if we remove the air from the bell jar completely, you won't be able to hear any sound, which actually proves that sound cannot travel in vacuum. And this is because there are no particles in vacuum which can actually carry the vibrations of the sound wave. Now looking at the second property of the sound wave, the sound waves are longitudinal in nature. What do we mean by this? All it means is that the particles of the medium, they oscillate in the same direction in which the sound wave is traveling. So if we look at the diagram for sound wave that we looked from the previous video, what it shows is the sound wave travels as compressions and rarefactions, right? And when we look at the direction in which these particles, right, they oscillate, these particles oscillate around their mean position, this direction and the direction in which the wave is traveling, that is the direction in which the disturbance is traveling, they are the same. So that is what is meant by sound waves being longitudinal in nature. The other kind of waves are transverse waves, which you will learn about in higher classes. Transverse waves are those in which the particles, they do not oscillate in the same direction. They oscillate in a different direction. Electromagnetic waves are an example of longitudinal waves. So we have learned two important properties of sound waves in this video. Sound waves need a medium to travel, which means that they can travel in solid, liquid, and gas, but sound waves cannot travel in vacuum. And we did a simple experiment. We looked at a simple experimental setup to prove this. The second property of sound waves is that they are longitudinal in nature, or they are longitudinal waves. So when a sound wave travels, the particles of the medium oscillate in the same direction as that of the propagation of the wave. Friends, I would recommend you to click on the red button below and subscribe now to the channel so that you will be instantly notified of whenever new videos are uploaded to the channel. Good luck, happy studying.